Introduction to Robotic. Supervised by Engineer Ibrahim Al-Ozalbi. Teammate: Salam Al-Jomail, Hisham Al-Shari, and Shadi Al-Mutari. Introduction to Robotic. The modern definition of a robot can be an electromechanical device which follows a set of instructions to carry out certain jobs. But literally robot means a slave. Robots find wide application in industries, and thus are called there as industrial robots, and also in sci-fi movies as humanoids. This and coming articles will provide an introduction to the robotic. The objective of the robotic. The project will be devoted to the development of aerial service robots, whose basic technologies can be adapted with minimal efforts to support human beings in a wide array of applications which require the ability to interact with environments which are otherwise inaccessible by ground robots. To prove the viability of the concept, the specific end-user air applications will be addressed, and prototypes of aerial service robots able to meet the end-user expectations will be developed. Robotic arm definition. A robotic arm is a robot manipulator, usually programmable, with similar functions to a human arm. The links of such a manipulator are connected by joints allowing either rotational motion, such as in an articulated robot, or translational, linear, displacement. The links of the manipulator can be considered to form a kinematic chain. Idea of the project. The idea for this ARM project extracted from the massive losses that can be avoided with artificial intelligence interactions, like for example open-close valves that located in critical location not accessible and designed for human occupancy, with a gas deduction. Whenever there is a gas leak, then the action will immediately take by the robotic arm to close the valve. Advantages of robotic arms. Precision and accuracy. First advantages of a collaborative robotic arm in the factory is that they are highly precise and accurate. This leads to improved quality of the products produced from the company and a reduction in defective products. Fast and efficient. Second advantages of the robot arm is that speed and efficiency are the main competitive advantage that robots bring to an industrial operation. They can perform multiple tasks and can help organizations improve their financial status and market position. Disadvantages of robotic arms. They need constant monitoring. First, disadvantages of robotic arms. Robots that have to be monitored at all times to ensure that they do not get any mechanical faults which would cause them to stall. This could lead to losses to the company. Robots are not creative or innovative. Second, disadvantages of robotic arms. Robots is that the limitations capacity to be creative or innovative. Robots can only complete tasks as they are instructed to through programming. Robots do not have the capacity to tell when consumer preferences are changing and what they want. Difficulties and challenges in implementing the idea. Shipment delayed from Amazon. Due to the health conditions in China and the spread of corona disease, the time limit for the arrival of the arm has changed, resulting in delays in the work to stabilize the arm, but with high enthusiasm and challenge, the arm was installed during its connection with less than 5 hours of continuous work. Coronavirus COVID-19. Due to the current event, the coronavirus COVID-19, we were unable to get the robot installed on time due to government request to minimize the gathering in 1P. So, we had to let one of us installing it and the rest are watching through a live feed. Drop of current. We encountered a problem when operating all the motors at the same time. Not all motors work due to the drop of current, and this problem has been fixed by changing the code used in the project so that there is a delay between each motor during operation. Distance between housing. Because some people lived in Abqaiq and the others lived in Al-Kibar, it was difficult to hold a meeting together during days of week and was limited to the weekend. Then the decision to ban curfews and not to leave homes came. This problem was solved through the use of new means of communication through FaceTime or Skype, and I had many meetings through it. Hardware requirements. 1. MQ2 sensors, 2 pieces. 2. Arduino Uno. 3. ARM robot. 4. Jumpers, male to male. 5. 6 servos, LDX218, LD150 and digital servo. 6. Breadboard. MQ2 sensors. Principal introduction. Sensitive material of MQ2 gas sensor is SNO2, stannic oxide, which with lower conductivity and clean air. How to use MQ2 sensors to detect gas. Using an MQ sensor that detects a gas is very easy. You can either use the digital pin or the analog pin to accomplish this. MQ2 sensors. 2D model of MQ2 gas sensor. If you purchased sensor, then you can use the following dimensions to create your own PCB for your application. MQ2 sensors character. 1. High sensitivity to combustible gas in wide range. 2. High sensitivity to LPG, propane and hydrogen. 3. Fast response. 4. Closing parenthesis wide detection range. 5. Stable performance, long life, low cost. 6. Simple drive circuit. MQ2 sensors technical data. In this slide just overview, and we'll see how to connect the MQ2 with Arduino, and which pins gonna use. As you see the photo which describe the MQ2 model, type, standard, which gas detection and etc. Arduino Uno is a microcontroller board based on the Amiga 328P datasheet. Arduino Uno, general pin functions. 1. LED, there is a built-in LED driven by digital pin. 2. VIN, the input voltage to the Arduino. 3. 5 voltage, this pin outputs a regulated 5 voltage from the regulator on the board. 4. 3.3 voltage, volt supply generated by the onboard regulator. 5. GND, ground pins. 6. IRF, this pin on the Arduino. 7. Reset, typically used to add a reset button to shields that block the one on the board. ARM robot, what are robotic arms used for? Robotic arms of all kinds are used today at every scale of manufacturing, from minutely detailed circuit board assembly to large volume heavy industries such as automotive production lines, as well as in a huge range of pick-and-place, conveyor belt applications. This means that it is important to know which types of programmable robotic arms are better suited to which sorts of environments and tasks before you begin planning a purchase. These will typically include ARM robot. 1. Load. All types of robotic arms have a given load capacity, including tools and attachments. 2. Orientation. This criterion is generally defined by the footprint and mounting position of the robotic arm. 3. Speed, particularly when choosing robotic arms for picking and placement applications. 4. Travel. Tolerances and accuracy over wider spans can be reduced in certain types of robot arms, due to arm deflection and differences in support framework design. ARM robot. 5. Precision. Certain types of programmable robotic arms are inherently designed to be more precise in their range of movements and articulations than others. 6. Environment. Consideration of atmospheric conditions and potential hazards, including dust, dirt and moisture levels, in the immediate working environment will be important when choosing an appropriate type of robotic arm for a specific location. 7. Duty cycle. This is essentially an evaluation of how intensively the robotic arm will be expected to perform. Jumpers, male to male. Jumpers is an electrical wire, or group of them in a cable, with a connector or pin at each end. Jumpers, male to male. Types of jumper wires. Jumper wires typically come in 3 versions, male to male female and female to female. Alligator clips, which consist of 2 spring metal clips connected by wire, are actually just fancy jumper wires. Servo motors are a type of electromechanical actuators that do not rotate continuously like DC-AC or stepper motors. Rather, they are used to position and hold some object. They are used where continuous rotation is not required, so they are not used to drive wheels unless a servo is modified. In contrast, they are used where something is needed to move to particular position and then stopped and hold there. Servo motors. How is the servo controlled? The guts of a servo motor, L, and an assembled servo, R, servos are controlled by sending an electrical pulse of variable width, or pulse width modulation, PWM, through the control wire. There is a minimum pulse, a maximum pulse, and a repetition rate. A servo motor can usually only turn 90 degrees in either direction for a total of 180 degrees movement. Types of servo motors. There are 2 types of servo motors, AC and DC. AC servo can handle higher current surges and tend to be used in industrial machinery. DC servos are not designed for high current surges and are usually better suited for smaller applications. Servo motor applications. Servos are used in radio-controlled airplanes to position control surfaces like elevators, rudders, walking a robot, or operating grippers. Servo motors are small, have built-in control circuitry, and have good power for their size. Other example and uses for the robotic arms. In food services and pharmaceuticals, the tools are designed to be used in harsher environments, where the potential for corrosion is high due to being washed at high pressures and temperatures repeatedly to maintain strict hygiene standards. Servos are also used in inline manufacturing, where high repetition yet precise work is necessary. Timeline. Week 4. Discuss with supervisor about the project. Week 5. Selected the team member and discussed the presentation topic. Week 6. Distribute the responsibility among the team. Week 7. Identified and purchased the hardware components. Week 8. Receiving the hardware component and assembled the robotic arm. Week 9. Developed the presentation of the project. Week 10. Identified the Arduino code. Week 11. Troubleshooting the robotic arm movement problems. Week 12. Tested the robotic arm. Week 13. Complete the presentation. Conclusion. Today we find most robots working for people in industries, factories, warehouses, and laboratories. Robots are useful in many ways. For instance, it boosts economy because businesses need to be efficient to keep up with the industry competition. Therefore, having robots helps business owners to be competitive, because robots can do jobs better and faster than humans can. For example, robot can build, assemble a car. Yet robots cannot perform every job. Today robots' roles include assisting research and industry. Finally, as the technology improves, there will be new ways to use robots which will bring new hopes and new potentials. Here is overview to the project. Robotic Arm. 2 yellow valves in each side and 2 MQ2 sensors. Now we will start test the project from right sensor then left side. As you see, we described the connection in board, so it would help us if we lose any connection. In the end, we can only express our sincere thanks to Engineer Ibrahim during the past period, and his method and a way to find a way to gradually operate the servos and arm until we got in the ideal way. Thank God, thanks for